Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from moving charges and magnetic field. Okay, our first question is a uniform conducting wire of length 12A and resistance R is wound up as a current carrying coil of current I in the shape of equilateral triangle of side A, square of side A. Okay, what did he give? He told that this is a wire of length 12A and its resistance is R. Now what did he do? He converted this wire into an equilateral triangle and to a square of side A. Okay, in both cases it's side A. Okay, now first let us think about this equilateral triangle. It's an equilateral triangle of side A. Okay, so he constructed this equilateral triangle with this wire of length L is equal to 12A. Okay, so to construct an equilateral triangle, one triangle, he requires a length of 3A, effective length of 3A. Okay, but he used 12A length. Okay, a wire of length 12A. That means he constructed four such equilateral triangles. Okay, such that 4 into 3A is equal to 12A. Okay, so the number of turns in this case is n is equal to 4. Okay, now let us go to a square. Okay, construct a square of side A, the effective length required is 4A. Okay, and we have length of 12A. So number of turns will be n is equal to 3, such that 4 into 3A, 4A into 3 will be equal to 12A. So in the case of equilateral triangle, number of turns is 4, and in the case of square, number of turns is 3. Okay, now what did he do? He asked us to calculate the magnetic dipole moment in each case. Okay, we know the formula for magnetic dipole moment as M is equal to NIA, where N is the number of turns, I is the current flowing through the coil, A is the area of the coil. Okay, and this magnetic moment doesn't depend upon the shape of the coil. It depends upon the effective area of the coil. Okay, now let us think in terms of equilateral triangle. Okay, the magnetic moment associated with equilateral triangle is M is equal to number of turns 4 into current flowing through the coil. He gave it as I. Okay, so I current is flowing through the coil. Similarly, I current is flowing through the coil. Okay, so I is the current flowing through the coil. A is the area of the equilateral triangle. That is root 3 by 4 A square. Okay, this will get cancelled. That is equal to root 3 I A square. Okay, now let us calculate the magnetic moment associated with this square. Okay, the magnetic moment associated with this square is M is equal to n number of turns, that is 3, into current flowing through the coil I into area of the coil, that is A square, that is equal to 3I A square. Okay, so the answer for this is fourth option. Now let us move to our next question. He told that he gave the formula for force F is equal to Q into V bar cross B bar, and he told us to take B like this, that is B I cap plus B J cap plus B naught K K cap. Okay, B naught K K cap, and he gave the value of Q and velocity vector V bar and force vector F bar. He is asking us to calculate the complete expression for B bar. Okay, so the formula for force is F is equal to Q into V bar cross B bar. Okay, now according to the concept of cross product, it is clear that the force vector, the force F will be perpendicular to the plane containing V bar and B bar. Okay, that is F bar is perpendicular to V bar and F bar is perpendicular to B bar. Okay, since F bar is perpendicular to B bar, that means F bar dot B bar is equal to 0. Okay, now let us use this thing. He gave the force vector F bar as this, and B bar vector as like this. Now, if you calculate F bar dot B bar, you'll get like this. That is, this is F bar, this is B bar. That is 4B minus 20B plus 12B naught should be equal to 0. That implies minus 16B plus 12B naught is equal to 0. Okay. If you take a common, you'll get minus 4B plus 3B naught is equal to 0. Okay. Now, for this to become 0, the value of B and B naught should be same. Okay. So, now if you compare here, B and B naught are different. Similarly, here, the values of B and B naught are different. That means these two will not be answers. So, the only possibility is either first option or fourth option. Okay. Now, in first option, B is 6 and in B naught is B is minus 6 and B naught is minus 8. Okay. Now, if you substitute here, what will you get? 24, 6 was 24, 8 3 is 24, minus 24. That is equal to 0. So, the answer is first option. Okay. So, the answer is first option. That is minus 6 I cap, minus 6 j cap, minus 8 k cap. Okay. So, this is a shortcut. If you want to go in a general way, okay, what you have to do? You have to write I cap, means you have to calculate the cross product of B bar and B bar. That is I cap, j cap, k cap. Okay. Now then calculate the write the coefficients of V bar. Okay. Here you have to write the coefficients of V bar, and similarly here you have to write the coefficients of B bar. Okay. And you have to calculate the determinant. If you calculate the determinant, you'll get some number into I cap plus some number into j cap plus some number into k cap, and you have to multiply this vector with q, that is 1. That will give you force. Okay, and he gave the value of value of force. Now what you have to do? You have to compare the coefficients of I cap on both sides, that is LHS and RHS. Similarly, coefficients of j cap and coefficients of k cap. Then you will get three equations. If you solve these three equations, you will get the value of B and B naught. Okay. Now let us move to our next question. Okay. An infinitely long straight conductor carries a current of 5 ampere. An electron with a speed of 10 power 5 meter per second is parallel to the conductor. The perpendicular distance between electron and the conductor is 20 centimeter at an instant. Calculate the magnitude of force experienced by the electron at that instant. Okay, electron velocity is 10 power 5 meter per second. Okay, now let us see what he gave. He told that this is an infinite long straight conductor. Okay, and to this current, to this conductor, a current of 5 ampere is flowing through the conductor. Okay, I is equal to 5 amperes. Okay, and what did he say? And an electron is moving parallel to the conductor. This is an electron. This electron is moving parallel to the conductor. The perpendicular distance between the electron and the conductor is 20 centimeters. Okay, so this is the perpendicular distance between electron and the conductor. What did he ask us to calculate? He asked us to calculate the force experienced by this electron. Okay, now this is an infinite long straight conductor, and current I is flowing through the conductor. We know that whenever current flows through the conductor, magnetic field will be set around the conductor, and the formula for magnetic field at a distance r for an infinite long straight conductor is B is equal to mu naught I by 4 pi r into sin alpha plus sin beta. Okay, so since it is an infinite long straight conductor, in this case alpha and beta values will be equal to 90 degrees. That means sin 90 and sin 90. Okay, that is, this will be 1 and this will be 1. That implies the value of the formula for B will be mu naught I by 2 pi r. Okay, Now you have to find the direction of this magnetic lines of force. Okay, so this magnetic lines of force will be circular, and you have to find the direction of this magnetic lines of force or magnetic field direction. For this, you will use this Ampere's right hand rule. Okay, so place your right hand such that thumb points in the direction of current. Then the rest of the fingers, okay, the rest of the fingers will be facing towards your y-axis. Okay, the current will be flowing towards your positive x-axis, and when you place your thumb towards positive x-axis, then rest of the fingers will point towards your positive y-axis. Now you have to hold the wire. In order to hold the wire, you have to curl your fingers from positive y-axis to positive z-axis. Okay, so the direction in which you curl your fingers will give the direction of magnetic field, that is towards your positive z-axis, shown by this arrow. Okay, now what is happening? The electron is entering into this magnetic field, and at this instant the electron is at a distance of 20 centimeters from the wire. Okay, since the electron is moving in magnetic field, it will be subjected to a force. The formula for that force is F is equal to Q into V bar cos B bar. Okay, that is equal to BQV sin theta, where B is the magnetic field at this point, Q is the charge of the charged particle, V is the velocity with which electron is entering into the magnetic field, and theta is the angle between B bar and V bar. Okay, so if you observe here, electron is moving like this. That means V bar direction is towards positive x-axis, and B bar is along this direction, that is along positive z-axis. Then the angle between B bar and B bar will be 90 degrees. That is F is equal to BQV. Okay, and again if you use your Ampere's right hand rule, then the force acting on this electron will be in downward direction. Okay, now let us substitute. The formula for B is mu naught I by 2 pi r into charge of electron, q into velocity of electron. Okay, now if I substitute the values, what will I get? Mu naught is 4 pi into 10 power minus 7 into I. What is the current? 5 ampere into charge of electron, 1.6 into 10 power minus 19 into velocity of electron, that is 10 power 5 whole divided by 2 pi into r. What did he give? He told that the perpendicular distance is 20 centimeters. That is into 20 into 10 power minus 2 meters. This will get cancelled by 2 times. And if you solve this entire thing, you will get the value of force as 8 into, that's what will I get? Yes. 8 by 8 16, this will get cancelled, that is yes, 8 into 10 power minus 9 19 20 10 power minus 20 newtons. Okay, so this is the magnitude of force that is acting on the electron, and the direction of this force will be in downward direction. Now let us move to our next question. A thick current carrying cable of radius r carries a current I uniformly distributed across its cross section. The variation of magnetic field due to the cable with a distance r from the axis of the cable is represented by. Okay, so this is a thick current carrying cable of radius r. Okay, of radius r, and I is the current flowing through this cable. Now what is he asking us to calculate? He is asking us to calculate. He is asking us to say how B varies with R from the axis. Okay, from the axis, how B varies with the R. Now, for this, let us consider a point P inside the cable, which is at a distance R. Now, if you apply this Ampere's circuit law, the circular Ampere loop, that is to this loop. Okay, if you apply this Ampere circuit law, you get the value of B inside the current carrying cable as B is equal to mu naught into J by 2 into R, where J is the current density. Okay, and this expression will be valid for all the points such that R less than or equal to R. Okay, and for R is equal to Kepler, which is nothing but the radius of the cable, you get the formula for B as B is equal to mu naught J by 2 into Kepler. Okay, now let us consider one more point which is outside the cable and which is at a distance R, and consider a circular ampere loop like this. Okay, consider a circular ampere loop like this. Now if you apply this ampere circuit law at this loop at this point, you'll get the value of B at this point as B is equal to mu naught I by 2 pi R. Okay, and this will be valid for R greater than small r greater than capital R. Okay, now if you observe, in the case of small r less than or equal to capital R, B is proportional to R, that is B is directly proportional to R, and for R greater than capital R, B is proportional to 1 by R. Okay, and for R is equal to capital R, the value of B will be maximum and its value is mu naught J by 2 into capital R. Okay, so from this we can conclude that for all points of R less than capital R, the value of B will increase linearly. That is, the value of B will increase linearly up to a distance such that small r is equal to capital R. And at small r equal to capital R, the value of B will be maximum, that is mu naught J by 2 into capital R. Okay, and for small r greater than capital R, the value of B, okay, the value of B decreases hyperbolically like this. Okay, so the answer for this is first option. If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. For more updates, kindly subscribe to my channel. Okay, the only thing that I expect from you is a single like, because your single like and a comment that you give will encourage me for making better videos. Thank you.